lazy and your test grades have been dropping, it's time to get your arrows popping. Hello. This is Mr. Witt with Fort Bend Tutoring, and today we have for you the difference quotient. That's right. Amen. Mr. Witt and Fort Bend Tutoring is in the house. That's right. And we have the topic of the difference quotient. That's right. This topic can be used in pre-calculus. It can be used in college algebra. It can be used in calculus. That is correct. Ladies and gentlemen, we are here today. Sauce God says, "What's up, Prof. Witt?" What's going on, Sauce God? Good to see you, sir. What's the deal? We got Lewis in the house. We got Sandra's in the house. Let's go ahead and get the chat up here. There we go. So just a reminder to subscribe to Fort Bend Tutoring, guys, FBT, as we bring you more fresh and live content. That is correct. Helping you out in your math endeavors. That is correct. Go ahead and click on that bell icon so that you can get notified when we are live and when we upload new content, fresh and free. That's correct. To help you out in your academic endeavors. Oh, yeah. So we have some good stuff for you today. Oh, that's correct. Let's go ahead and check it out. So the difference quotient, guys. The difference quotient. Here it is, right here. Let me get my title and view here. Let me get it together. If I can get my words together, we have the title, the difference quotient, and it is commonly seen as such: f of x plus h minus f of x divided by h, where x cannot equal to 0. But of course, x cannot equal to 0 because that would make the whole thing undefined. So we have the difference quotient. It is also seen as such. That's right. Especially in the calculus class. You'll see it as f of x plus delta h, delta x minus f of x divided by delta x. All right. And you could use this, to find the slope of the secant line of a function. Okay. And they'll even take this a step further and eventually show you how to find the derivative of the function, aka the slope of the tangent line, using a similar form of this right here. Especially when it's applied to a limit. Amen. So let me get warmed up here. Let you guys get warmed up here. And we will be doing the following problems right here. Let me check it out. I just wanted to give you guys a taste of what you'll be seeing today. That's right. Lewis says find the prime derivative. That's right, the first derivative. Absolutely. So we have a snippet of what you can expect in today's lesson. I wanted to go ahead and map it out for you guys. We have 12 problems that will be covered today. Oh yeah, here we go. Check them out. There we go. And we'll be applying the difference quotient to each and every one of these problems together. That's what we have in store for us today. Wanted to make sure that you guys were aware of what was going to be in store for you today. So I went ahead and made a nice little list for you so that you could see that we will be covering different types of functions and applying the difference quotient to it so that you could be better prepared for your college algebra courses, for your pre-calculus courses, for your calculus courses. FBT is prepared to help you today. That is what's going on. Oh, yeah. Yeah, I came prepared today. I'm ready to play. I'm ready to play with you today with these math problems. That's exactly what's going on. Let's go ahead and move on here to the next page. All right, go ahead. Get it in. Darian is in the house. What's going on, Darian? Darian Jones is in the house. What's up, baby boy? Good to see you. I remember that you was Sauce God. You could have left it like that, Darian. It's all good. I had one of my students chiming in today with me, Darian Jones. What's going on, Darian? Let's go ahead and get into business, guys, with problem number 1 here. It says to find and simplify this difference quotient. And we have f of x plus h minus f of x divided by h, where h does not equal to 0 for the function f of x equals 4x. So the first thing that you want to find out is what the difference quotient is requiring of you. It's saying that it needs you to give them f of x plus h. Well, we don't have that right now, okay? We don't have that right now. So let's find out what that value is. So if we were to find out f of x plus h, that means that you're going to be replacing, and let me just clean this up real here because it's looking a little ugly. Let me go ahead and fix that. So the first thing we want to find is f of x plus h by replacing every x in our original function with x plus h. And it'll look just like this. We'll have 4 times the quantity of x plus h. And you can go ahead and distribute this if you like by getting your arrows popping around here. That's right. Get those arrows popping, as you know I love to do with the distributive property. So we find out that f of x plus h is equivalent to 4x plus 4h. Now we can plug these values into the difference quotient and attempt to simplify it. So it's asking us to write down the f of x plus h first. Well, that value is 4x plus 4h minus the original value of f of x, which is 4x, all divided by h. Assuming, of course, that h does not equal to 0. From this point, we'll be simplifying this. So the 4x's will cancel out here. We end up with 4h divided by h, and then canceling out those h's, you'll end up with a value of 4. Chris Patrick says she wants to identify my slope. That's right. Well, we're going to be identifying the slope of the secant line by using the difference quotient. Amen, amen. And if we have the limit as it approaches 0, then we'll be defining the slope of the tangent line, aka finding the first derivative in calculus. And we will red box this, ladies and gentlemen. That's exactly what we'll do, because Lewis has the answer. Sandra has her answer correct. Amen, amen. Oh, you guys came prepared today, didn't y'all? With the correct answers. Let's go ahead and show the world that you guys were ready with your answers. Look at you. Sandra with the correct answer. Lewis with the correct answer. And Darian Jones in the house. That's what's going on today, guys. So we're just going to be blazing through these problems here, helping those in need, keeping our concepts of mathematics fresh over the summer, not letting off the gas, making sure that we're moving forward as we prepare for our next academic endeavor. That's right, letting mathematics enhance our capabilities. That's right. That's what we're here to do. We have problem number 2, guys. We have problem number 2. Find and simplify the difference quotient. We have, of course, that difference quotient of f of x plus h minus f of x divided by h, where x does not equal to 0, for the function 5x plus 6. This function f here. That's what we want to use here. So we're going to start out by, first of all, finding out what this value of f of x plus h is. And we're going to do that by replacing all the x's in the original problem with x plus h, and then simplifying. So notice that I've replaced the x in the original f function with x plus h. We will then distribute, all right, and simplify as much as possible. So as I get my arrows popping here, I have the following. I have 5x plus 5h plus 6. All right. And then I'll be plugging in these values right here and then simplifying. Darren Jones says, I'm so glad I'm in the 9th grade because these problems look too hard. Oh, no, they're not too hard for you, Darren. Not too hard for you, sir, but you will not need it in 9th grade. So you can use this as early as Algebra 2. That would be 11th grade, maybe, depending on the course. But most likely you wouldn't see a problem like this until pre-calculus 12th grade for most people in the United States of America. That's right. And then, of course, in college algebra as well as you enter college. So let's go ahead, now that we have this f of x plus h, guys, we're going to go ahead and plug this into the quotient, the difference quotient, by plugging in 5x plus 5h plus 6 minus our original quantity. That's going to be minus the quantity 5x plus 6 here, all divided by h. That's what we have. Then, of course, you'll be distributing this negative and then combining your like terms. So I could rewrite this as 5x plus 5h plus 6 minus 5x. Excuse me, that's going to be a minus 6 right here. That's a negative 6, all over h, guys. From here, we're going to be simplifying this, as we know that the additive inverses, these opposites of those 5x's, those will cancel out. We also know that the 6's will cancel out. We end up with 5h divided by h, and these h's will simplify, assuming that h does not equal 0, to end up with the result of 5, just as Lewis has predicted, just as Sandra has predicted. And Simone is in the house, guys. Simone is in the house. How you doing, Simone? Good to see you. Good to see you as we throw you up on the screen here in the chat. Let's go ahead and continue, guys, as we just plow through these problems today with problem number 3. That's right. That's right. So Lewis says, notice how Mr. Witt uses parentheses with the f of x. That's right. That is a label for the function. It is the name of the function. In this case, this name of the function is f. So they could use f of x, g of h. They could use any type of name that they wish to label the function. This is so that you can differentiate from one function to another, especially if they give you several in one problem. So this function notation here, this f of x, that is just the name of the equation, the name of the function. Amen, amen. Let's go ahead and dive into problem number 3, guys. That's right. So here's the deal. Oh, you're talking about as I distributed the negative in that previous problem? Absolutely, Lewis. What's going on, Joel? Can you do a live video about slope? All right, I can put that on the agenda, Joel. All right. But just note that I do have already posted on the YouTube channel a video for finding the slope. But yeah, we can do that live one day. That's not a problem. All right. Simone, we just actually getting started. You didn't miss too much. You didn't miss too much. So you're good. Bina's in the house. How you doing, Bina? Bina is here to go today. Let's go ahead and get into problem number 3, guys. So we have our function f of x equals to 8 minus x. And what we'll do here is we'll first of all find out what our value of f of x plus h is, because this is a requirement for using the difference quotient. We need to have that value of f of x plus h first. So therefore, let's go ahead and replace all the x's in the original function with x plus h. So this is definitely going to test how comfortable you are, I should say, with function notation and evaluating functions. So here you're going to replace the x with x plus h. You'll be distributing the negative here so that you'll distribute that negative to simplify it as I get my arrows popping here. We'll have 8 minus x minus h for your result, that value of f of x plus h. And now we can plug this information in, guys, to the difference quotient. So the difference quotient wants us to write down what the value of f of x plus h is first. So we will rewrite it as 8 minus x minus h minus our original function of 8 minus x, all divided by h. This allows me to then show that I'll be distributing that negative in front of that quantity of our original function f, just like this, and we'll end up with 8 minus x minus h minus 8 plus x, all divided by h. From here, simplifying this, our additive inverses, of course, will cancel out to 0 in the numerator. The 8's are canceling out. We'll end up with negative h divided by h, which reduces, simplifies, guys, to negative 1, just as Bina and Lewis has predicted. Amen, amen. And Lewis, just to let you know, that is not the derivative unless we have it set up as the limit as x approaches 0 of that difference quotient. So in its current form, we're looking at the slope of the secant line, not the slope of the tangent line. And that's the difference between the difference quotient and actually the definition of the derivative. All right. So just to let you know, we have the result for problem number 3 in a red box. And we're so moving on, guys. That's right. The slope of the secant line. That's right, Bina. The secant line is a line that goes through a curve, all right, or a function twice, all right. So, for instance, if I were to draw a diagram of this, if I had, let's say, a parabola, that looked like this, and I had a line going through it, and notice that this line hits this parabola in more than one spot. This is considered to be a secant line. That is a secant line, a line that goes through a function in two places. That's the slope of the secant line in this case. Whereas, eventually, if you apply the limit as x approaches to 0 or h approaches 0 to this difference quotient, it'll give you the slope of the tangent line. And the slope of the tangent line would look like this, because the tangent line only hits the function in one place. So that is the difference between the two forms of the difference quotients that you'll see utilized in pre-calculus as well in calculus courses. All right. Amen. Amen. So here, guys, we are looking at finding and simplifying the difference quotient f of x plus h minus f of x divided by h, where h does not equal to 0, for our function here, f of x equals to 7. That's right. So Lewis says that the answer is big 0. It's a big fat 0. Sandra also says that the answer is 0. Let's see why they would say that. First of all, let's go ahead and find out what f of x plus h is first, guys. So notice that we are supposed to be replacing all the x's in the original function with x plus h. You can even go so far, guys, as to say that our original function here, and let's go ahead and use a eraser, that our original function is equivalent to 7x to the 0 power. Okay, so if you wanted to truly show a lot of work for this, okay, you could rewrite this by saying that this is equivalent to plugging in x plus h into this situation, where you would still end up with 7 in this case, because 7 times x plus h raised to the 0 power is still going to give you 7. All right, and then plugging in this value into our difference quotient here will look as follows. It'll look just like this. We'll have 7 minus 7 divided by h, so that you end up with 0 divided by h. And assuming that h does not equal 0, this answer, as Lewis would say, is a big fat 0. The answer is 0. And of course, we will red box this answer here, guys, just like that. All right, so keep in mind that x plus h to the 0 power is equivalent to 1. All right, so let's go ahead and write that step out as well. Let me go ahead and give you guys some good meat on the bone. There you go. Give it to you like that. So we are showing that even though you didn't see the variable, if I can get my words out here, notice that you didn't originally see the variable x in your function, you can show it by saying that you had it as 7x to the 0 power, and then utilize this to replace your x plus h into the original function, and then simplify from there. All right. No. That's not how you would go about doing it. See, notice that we replaced that x, Bina, with the x plus h, and then went from there. Now, even if you had distributed that, you would still end up with the same result that we have. Simone is asking, is this college algebra 2? No, it's not college algebra 2. It's simply college algebra. And college algebra 2, if that is a course that I've never heard of before, Simone, it would most likely be called pre-calculus. All right, so if that's the case, then yes, this is college algebra 2. All right, so normally it's defined as college algebra and also pre-calculus, and it's definitely used in calculus courses. So all of this is just preparation for the higher level mathematics courses. Let me get some water here. I'm dying. Thank you so much, Chris, for watching that 2-minute ad just for me. I appreciate your commitment to your academic endeavors and hanging out with Mr. Witt and Fort Bend Tutoring today. Thanks so much, Chris. Good looking out. Sandra's laughing about that. Let's go ahead and show Chris a little love on the screen here. All right. No juice. That's right. No juice today. I need to make sure I'm drinking more water, Lewis. I've been drinking too many sweets lately, man. Everything I've been drinking, apple juice, orange juice, too much sugar. I need to balance things out. Everything in moderation, Lewis. So here for problem number 5, guys, it says to find and simplify the difference quotient f of x plus h minus f of x divided by h while h does not equal to 0 and our function. That's right, Obina, we got to stay healthy. Our function here is f of x equals negative 1/2 x plus 9. So notice that this is the first function where we have a fraction involved. Let's see how this plays out. The first thing remains the same. We do not know what the value of f of x plus h is. We need to find that out. So let's go ahead and distribute that negative 1/2 into the quantity x plus h. We'll have plus 9 here. We can go ahead and distribute that negative 1/2 to end up with negative 1/2 x minus 1/2 h plus 9. All right. And as these are unlike terms, we're going to leave this value exactly as you see it right now. Okay. So this is going to be our value for f of x plus h. And you know what? I think I want to put this in a purple circle. So we're just going to keep track of this value here, and of course the original function is what we'll need to use to plug into the difference quotient. And once again, guys, the difference quotient, what we're dealing with today, is used in pre-calculus, college algebra, and calculus courses. Okay, so that's why we're reviewing this as we get you prepared for that next level of mathematics. Let's go ahead and plug in these values here. We'll have the negative 1/2 x minus 1/2 h plus 9 minus our original quantity of negative 1/2 x plus 9. That's that original f of x, all divided by, I hate that, let's fix it, all divided by h here. Here we go. And then simplifying this after distributing that negative here in the numerator, we'll have the negative 1/2 x minus 1/2 h plus 9 plus 1/2 x minus 9, all divided by h here. Okay, that's what we have thus far. Let's go ahead and get everything in view for you. Sorry about that, guys, as you were not in the know. Okay, I had it hidden. Sorry. So the 1/2 x's will cancel out in the numerator. The 9's will cancel out in the numerator. You'll be left with negative 1/2 h divided by h. These h's will cancel out then to leave you a result of negative 1/2, which is your answer, which matches Sandra, which matches Lewis. Lewis is very fast with it. That's right. I'm thinking Lewis is getting started as soon as I show the problem, though, Sandra. So he might have had a little head start on you. But either way, Lewis is definitely ready. He's definitely prepared, and he's definitely efficient with getting his correct answers. That's right. Good stuff, Lewis. No, Lewis, that's a very good question. Lewis is asking, guys, if the h's don't cancel, is it wrong? That is incorrect. All right. It is not wrong in that case, Lewis. That is just going to be the result. You'll just have an h remaining in the problem. And that happens from time to time when you're doing these. So it's not wrong if it still has the variable h left in the result. It is not wrong. You just leave that h right there where it is. Obina says, that's right. I would have inputted my answer, but I was coughing badly. Well, I hope you're not too sick over there, Obina. All right. Drink some water. That's what I'm doing. Clearing that throat out. Here we have problem number 6, guys. In problem 6, we have find and simplify the difference quotient f of x plus h minus f of x divided by h, where h does not equal to 0 for our function f of x equals to 1 divided by 2x. That's right. We have another rational expression, guys. We have a rational expression as our function that we need to input into the difference quotient. Okay, so let's go ahead and see how that plays out. Once again, we'll be finding out this value of f of x plus h that the difference quotient is requesting. All you have to do is replace the x with x plus h just like that. All right, and I believe for this particular problem, I think I'm going to leave it as 1 over 2 times the quantity of x plus h. I'm thinking I might leave it just like this for now because this looks ugly as it is. So let's see how this plays out in its current form. All right. We may have to adjust it somewhat later on, but for right now, we'll leave it as 1 divided by 2 times the quantity of x plus h. I don't think distributing the 2 in the denominator is going to help us right now. All right, so that being the case, let's go ahead and plug this into the difference quotient here. Let's go ahead and change this ink back to black and plug it in. We'll have 1 divided by 2 times the quantity of x plus h minus our original function, which is 1 divided by 2x all over h. Okay, and let me put this in view, forgetting to put it in view for you guys. So this looks ugly. I hate everything about it, I believe. I think to get rid of the complex fractions, let's go ahead and see what that looks like, guys. Let's see what happens if we multiply the numerator and the denominator by the overall common denominator, which is going to be 2hx times the quantity of x plus h. Let's see if this helps us out. I know that in some textbooks, some authors would just let you stay where we are right now, but I'm thinking that we need to see what would happen if we try to get rid of the complex fractions. Okay, so I'm multiplying each and every term, guys, by this 2hx times the quantity of x plus h. We'll multiply this out to every element of our complex fraction here to see if we can eliminate the extra denominators in the problem. If we were to multiply this first term of 1 divided by 2 times the quantity of x plus h times this 2hx times x plus h, the 2 and the x plus h's will cancel out to leave us with hx in the numerator. All right, and that's supposed to be a minus sign right here. If we were to multiply this negative 1 over 2x times the 2hx times the quantity of x plus h, the 2x's will cancel out to leave us with h times x plus h, all divided by this 2h squared x times the quantity of x plus h. All right, so this is what we have thus far, guys. Now, I do know that we could factor out an h in the numerator. Factoring out an h in the numerator will eliminate one of the h's. So if you guys bear with me because I'm running out of space here, one of these h's from each of the elements within this rational expression will be canceled out. Okay. If you then distribute the negative in the numerator, you'll have x minus x plus h all over 2hx times the quantity of x plus h. Well, what happens from here is that the x's in the numerator will cancel out, right? This 1h cancels out with this x here, so therefore you end up with 1 over 2x times the quantity of x plus h as the final result here. And that is exactly what Bina has. Good job, Bina. You killed that problem. You killed that problem, Bina. Good job. Let's go ahead and show you some respect here and get your answer on the screen. There you go. That's right. Bina's in the house. Bina's in the house. But hold on, Bina. Watch out. Bina, you have... let's see here, Bina. What do you have here? Yes, Bina is correct because this was supposed to be a negative h. Good job, Bina. I did say we were distributing the negative in front. That would have gave us a negative x minus h. Let's fix this because Bina is correct. There you go. Distributing this negative in front. All right. I made a mistake. When we distribute this negative, the negative times the x gives you negative x. The negative times the h gives you negative h in the numerator. That's right. So that when you simplify everything else, when you simplify that negative h divided by that h there, you'd end up with negative 1 in the numerator. Good job. Good job, Bina. You killed it. You killed it. Good job. And that's why I'm glad you guys are here to keep me honest on this. Simone, I understand it is a lot to take in, but the focus of all of this is just this difference quotient formula right here. This formula this formula helps us in various aspects of mathematics, especially the higher up in math that you go, especially when it comes to derivatives and calculus and stuff like that, and finding the slope of the tangent line of a function, finding the slope of a secant line of a function. We can utilize this difference quotient to help us out in that way. Michael Burns says, Mr. Witt, I just wanted to express the love I got for you. I finished all my exams yesterday, and if it weren't for you, I don't think I was going to make it. Thank you, Mr. Whittington. My pleasure, Michael. Congratulations. So proud of your success there. And definitely, Lewis, that is a double red box for Bina, because Bina kept me in check and helped us make sure that this answer was correct here, because I made a mistake and did not distribute that negative correctly. Good job. Bina says, find the LCD of f of x plus h and f of x. Adjust the fractions based on the LCD. All right. That is correct. So what happens here is we were utilizing several things. Not only were we dealing with the difference quotient in here, but when it came to this step right here, we had complex fractions, especially this is dealing with Simone's question. When you have fractions within fractions, that is not a proper form to leave your answer in, Simone. So what you do is we can use complex fractions as far as simplifying those complex fractions to get us to a proper form of the answer, which is what we have here. And it also helped us simplify the problem because in a lot of these cases, you actually want to try to eliminate as many of the H's in the problem as possible. All right, especially the ones that would make the problem undefined if you were to replace H for some reason with the number 0, especially when you're trying to find the derivative of this function. What's going on, Genesis? Good to see you. So thanks again, Bina. It was in the house for that. And speaking of Bina and his perfect answers, I wanted to just let you guys know that we can you can always set up a paid online tutorial today with Fort Ben Tutoring. That's right, with Fort Ben Tutoring, FBT, at tutormemath.net, and you can even get me one-on-one to assist you with your math classes. So definitely check out tutormemath.net, our website, where you can set up a paid online tutorial today. That's right, you can hire Mr. Witt to be your personal tutor to assist you in your mathematic endeavors. And that's right, I'll even bring Bina along with me so I can make sure I get the answers right. All right, let's go ahead and continue on with our next problem. Lewis says, could you use the conjugate? Most likely you could, Lewis. You probably could use the conjugate. It might have been a little messier, but yeah, you had two terms in the denominator, I believe, at one point, or in the numerator rather. So yeah, you could have multiplied by the conjugate of that and see if that would have assisted you. But definitely using the LCD overall will definitely help. Obina says, I think the conjugate is more geared toward rationalizing fraction. Yes, it is, Obina. However, multiplying by the conjugate is utilized in trigonometry, verifying trig functions, and also it can be used to help you out in situations like this. Why don't you guys go ahead and multiply by the conjugate and see if that helped out. See if that helps you simplify it. All right, good deal. So problem number 7, guys, we have the following. Genesis is in the house, by the way. Let's go ahead and show Genesis a little love on the screen here. Genesis is right there, guys. There's Genesis and the rest of the chat helping me out today on the difference quotient topic. Let's keep it moving, guys. Problem number 7. Find and simplify the difference quotient for the function 1 divided by x plus 1. Michael is in the house, just stopping by to take care of everybody. And Mr. Witt, I'm taking my beloved out for dinner as we speak. Much love. We'll share the love with your beloved Michael. Thank you so much for stopping by. I really appreciate that. And I always am happy to help. Congratulations. All right, guys, let's go ahead and find out what our value of f of x plus h is. We're going to replace all the x's in this original function with x plus h. So we end up with our quantity of f of x plus h being 1 divided by x plus h plus 1. This is what we have thus far. If we're plugging in these values directly into the difference quotient, Simone, just bear with us. We're just using some substitution here. We'll end up with 1 divided by x plus h plus 1 minus the original function, which is 1 divided by x plus 1 all over h. Okay, and what I'll be doing is I'm going to, once again, guys, if you guys want to try that conjugate, you go right ahead. I'm not messing around with that conjugate because that's going to be a hot mess. I know it will. And you see, I was struggling by multiplying with just the LCD. I'm not going to even take a chance. I'm going to multiply instead, guys, by the overall LCD here, which is going to be h times the quantity x plus 1 times the quantity x plus h. I'm going to multiply that to each and every element in our rational expression. That's what I'm going to do. And this was going to be x plus h plus 1, as I'm already making a mistake here. There we go. This factor is x plus h plus 1 that we need to multiply by. There we go. All right. So the downfalls of doing it live is being able to make mistakes on the fly that you may not catch unless you got people like Bina in the house. What's going on, Kate? Even math and moderation, not possible. Yeah, that's not possible because math is all around us, Kate. You're absolutely right. Let's go ahead and distribute here, guys. So distributing each and every element within this rational expression by our LCD, which is h times the quantity of x plus 1 times the quantity of x plus h plus 1. Oh, Bina is already coming through with a result. Let's see what happens here. I know that my quantities of x plus h plus 1 will cancel out to leave me with h times x plus 1. That's from multiplying the 1 over x plus h plus 1 times this LCD here. We would end up with h times x plus 1 in the numerator as that first term. This is going to be minus here. The x plus 1s will cancel out. So I'll have an h times x plus h plus 1. Then in the denominator here, we'll end up multiplying straight across to get h squared times x plus 1 times x plus h plus 1. And so this is what we have thus far. From here, one of the h's will cancel out, right? They're gone. So we will try to simplify this by rewriting it as x plus 1. All right. Distribute that negative to get negative x, negative h, negative 1 all over h times x plus 1 times x plus h plus 1. All right, I'm really running out of room here, but I believe that's where I want to be. All right, and you know what? Let me fix that denominator, guys, because I don't know why I'm over there so much. I think I was trying to center that h. I forgot that I had the rest of those factors to write down. So let's fix the way that looks because it was ugly, and we don't want to be ugly. Oh, my God. As I say ugly, I'm making it uglier. How did that happen? There we go. Better, guys. I believe that's better. Now, in the numerator, the x's will cancel out. The 1s cancel out. We have negative h up there, which will simplify. So Bina is already correct that we will have that negative 1 in the numerator. Okay? So it's negative 1 in the numerator now. I got it together this time. The h's will cancel out, and then you'll have the quantity of x plus 1 times the quantity of x plus h plus 1. All right, guys, we got it together this time. What do you think, Obina? Did I do it right this time, guys? Lewis, Sandra, I think I got it right this time. Here we go. Good stuff. Finally got the right answer. Here we go. Done and done. So that's the way I would attack this problem, guys. So I know a lot of people online are requesting how to use a difference quotient when you have a rational expression, aka a fraction involved, such as this. Well, that's exactly what you need to do. You need to multiply everything by the overall LCD and simplify that. In other words, get rid of the complex fractions. And if one of the moderators, I believe, Lewis, that you may be the only moderator in here right now, if you can go ahead and slap a link in the chat for complex fractions, that'll give everybody a good idea of what this process is that I'm using to simplify the complex fractions in this case. That is problem number 7, guys. Done and done. And this time I did it all on my own. All right, we have problem number 8, ladies and gentlemen. Notice that we have a square root involved in this function here. That's right. So let's see what happens with the radicals. We want to find and simplify the difference quotient, f of x plus h minus f of x divided by h, where h does not equal to 0 for f of x equals negative 3 times the square root of x. Let's see what happens here. Let's first of all find that quantity of f of x plus h first. That's the first thing we want to do, guys. And you're going to be replacing all the x's with x plus h. So this is what we have thus far. Oh, yeah. Just like that. From here, we're going to go ahead and plug in these values into the difference quotient. Let's go ahead and do just that. We'll rewrite our numerator as negative 3 times the square root of x plus h minus the original function, which is negative 3 times the square root of x, all divided by h. We're going to simplify this. We know that we need to find the opposite of negative 3 times the square root of x. So you'll end up with negative 3 times the square root of x plus h plus 3 times the square root of x, all divided by h. And notice, I believe Lewis asked about this earlier, that what happens when you still have the variable h, that value h, in your result? Nothing. Just leave it alone, because that's it. Go ahead and slap a red box around this, guys, because this is the answer. Yeah, you could try to multiply by the conjugate, But then you'll have radicals in the denominator, and that's going to be a lot worse. It's going to be even uglier than what it is. There it is. So, done and done. That's it. So in a situation like this, Lewis, where you have h's left in the denominator, they stay there. It is what it is. It is what it is. So we just wanted to find that most simplified form of the difference quotient. That's what they're requesting. What's going on, Alex? Alex says it's easy peasy. Definitely, this problem was easy peasy. I'm thinking that previous problem, Alex, was a bit tougher for some people because of the complex fractions. But this problem here, absolutely, it was plug and play. Good job, Alex. Let's go ahead and show Alex a little love on the screen. Alex is in the house with us today, guys. What's going on, Alex? Thank you for the easy peasy. We have now problem number 9, guys. Problem number 9. Let's see if this problem will also be easy peasy, as Alex says. We're going to have the f of x plus h value. All right, we'll be replacing that x with x plus h, so you end up with the square root of x plus h minus 4. Then plugging this into the difference quotient. Bina says, well, there's no way to simplify it. That's right. Yeah, you just stuck with what it is. Absolutely, you just stuck with what it is. So plugging in the values here, you'll end up with the square root of x plus h minus 4. That's supposed to be a minus sign there. I think I want to fix it. Yeah, let's rewrite this because it was just God ugly. Then there's going to be minus. Nope. Better 4 coming up. There we go. That's a better 4. And now let's put everything in view here for you guys. It's going to be all divided by h. And there it is. Can't do anything with this. All right. Yeah, you can multiply the numerator by the conjugate, but then why would you want the radicals to be in the denominator? Because that's where they're going to be going. All right. So we're going to just be stuck right here. So these problems here, Lewis, do exactly as you requested, and that is it answers the question, what happens if you can't cancel out that h in the denominator? The answer to that, nothing. Nothing. You just leave it right there. That's right. You put a box around this answer, and you give it to your teacher. That's what you do with that. Done and done. Bina's in the house. You're on fire today, Bina. You're on fire today. Lewis, thank you so much for including that link for complex fractions in the chat so that Simone can check that out. All right. So that one's for you, Simone. All right. That link right there, that shows the process of what we were using on those previous problems. I believe it was problem number, what was it, 6 and 7 maybe? Problem number 6 and 7 as far as simplifying those complex fractions. Yeah. Thanks a lot, Lewis. You are a gentleman and a scholar. Good stuff. All right, let's continue. We have problem number 10. With problem number 10, we want to find and simplify the difference quotient. Yeah. And for this function, it's a quadratic function. We have f of x equals x squared minus 3x. That's right. Let's see what happens when you have some higher exponents involved here. When the function is not linear, when the function is not a rational function, when the function is not a square root function. What happens with that situation? Well, let's find out. The first thing is you'll still need to find out what that value of f of x plus h is. So when you're replacing all the x's with x plus h, let's see what happens in this case. You see that? Yeah. And you can't just willy-nilly just distribute that 2 within those parentheses. That's a binomial, guys. You can't do that. You'll need to expand this. Okay? That's exactly what you'll need to do. So left side, of course, is still f of x plus h. But on this right side, go ahead and expand this so that it reads x plus h times x plus h minus 3 times the quantity of x plus h. And this is what we want to simplify from here. Oh, yeah, we're about to have fun because these arrows are about to be popping everywhere, guys. That last arrows, it kind of sucked. There we go. We got arrows popping everywhere with the distributive property. Let's multiply this out here. We'll end up with x squared plus hx plus hx plus h squared minus 3x minus 3h. This is all, guys, just to find the quantity of f of x plus h. We haven't even begun to substitute into the difference quotient yet. No, we have not. So, combining our like terms, you have x squared plus 2hx plus h squared minus 3x minus 3h. This is what we have thus far. And you know what? I'm gonna need some more room here. Let's go ahead and insert a page. There we go. Let's get this straightened out here. Okay, I may need another page for the next problem after that. Let's go ahead and hook that up. Put all this in place. Keep that going. All right. Let's go ahead and hook all this up. I should have been better prepared. I know this. All right. So we had this x squared plus 2hx plus h squared minus 3x minus 3h. That's what we had, guys. We're going to go ahead and steal this for a second. Let's go ahead and steal this. Let's go ahead and hook this up. Go ahead and steal it. I'm stealing things right now. All right, there we go. And let's set up the numerator of our difference quotient. We have this value right here. Okay? It's going to be minus that x squared, the quantity of x squared minus 3x. All right? So just to verify that the original function is what it is, yes, x squared minus 3x, just making sure. This is going to be our numerator all over h. Okay, so we had our quantity of f of x plus h, which is here. That's this quantity right here, minus our original function of f of x, all divided by h. I will be distributing, guys, that negative into this set of parentheses here in the numerator. We will rewrite this as x squared plus 2hx plus h squared minus the 3x minus 3h minus x squared plus 3x all over h. That's what we have thus far. Bina has an answer. Lewis has an answer. What happens in the numerator? The x squareds will cancel out. The 3x's will cancel out. And you will end up being able to factor out an h in the numerator. Let's go ahead and show that. If I factor out an h in the numerator, we'll have h times 2x plus h minus 3 all divided by h, where we can cancel out the h's at this point. So that your answer here is 2x plus h minus 3. Notice once again, Lewis, how we have h in our answer. Once again, you can have the h remain as part of your answer depending on the original problem. Okay? So I'm glad, so glad that we had a different look of all of these different types of problems where you're dealing with the difference quotient. All right? So I'm going to pat myself on the back right here for collecting these different types of problems. I am. Just a little, just a little congratulations to myself. It's an eclectic mix. Thank you. Of problems. So Lewis says that notice that the h could be a 0. It could not, Lewis, in this case, because remember our condition for the difference quotient in these problems, in these series of problems, is that h cannot equal to 0. So you're still trying to refer to the limit as h approaches 0 when you're finding the slope of a tangent line, aka find the derivative. The difference quotient in and of itself, h cannot equal to 0. Because it's part of the stipulations at the beginning. All right. So for instance, let's check out our next problem here. Notice, what does it say at the beginning? It says that we have our difference quotients here. And what does it say about h? It says h cannot equal to 0. So that's already defined as far as the values of what value h can be. That's right. So Lewis is now understanding that only deals with when we have the limit to 0. That's right. That is going to change this purpose from being the slope of the secant line to being the slope of the tangent line. And that's when you have that limit as h approaches 0. But in this case, h cannot equal to 0 outright. And therefore, you wouldn't have to worry about that h going to 0 in that case. All right. It's not that they don't have problems like that. It's that these problems are not like that. That's the only difference there. So here, guys, we have our function for problem number 11 being x squared plus 5x minus 1. All right. And just so the world can see, Lewis definitely understands now, guys. He says, yes, the limit to 0. Gotcha. All right. That's Lewis in the house, guys. So we just helping out Lewis, not bullying Lewis at all. So we don't bully here. We help people. All right. So we already are given our f function right here. However, we do not know the value of f of x plus h at this current time. We need to find out what that is. And how do we find that out? We find that out by replacing all the x's in the original function with the quantity x plus h. So note, this is going to be the process for finding out that value. All right. Remember, just like in the previous problem, you'll need to expand that binomial squared. So this is the same as x plus h times x plus h plus 5 times the quantity of x plus h minus 1. Then you'll go ahead and distribute. That's right. Go ahead and get those arrows popping. So with those arrows popping here, because you know how much I love the distributive property. It's my favorite. I can't help myself. It's going to be x squared plus hx plus hx plus h squared plus 5x plus 5h minus 1. And that is what we have thus far as we distribute in the process of simplifying the quantity of f of x plus h. From here, you'll have x squared plus 2hx plus h squared plus 5x. This is going to be plus 5h, then minus the 1. There we go. I was jumping the gun on that minus 1 there. Let's go ahead and steal this. We'll need this for our next step. All right, copy that. And for the numerator of our difference quotient, guys, we will have the following. Let's go ahead and line that up. Paste this in here. This is going to be minus, guys, the quantity of x squared plus 5x minus 1. Ugly one. Better one. All right, and what I want to do is I want to verify that that function is correct. Yes, x squared plus 5x minus 1. Just wanted to make sure that our f of x was correct. All right, and all of this is going to be over h. So now we'll be distributing this negative here. So I'm just showing all my steps here, guys. Just trying to take my time with it so I don't lose anybody. And I'll be distributing that negative on the outside of the quantity there, that negative in front of those set of parentheses. We'll have x squared plus 2hx plus h squared plus 5x plus 5h minus 1 minus x squared minus 5x plus 1 all over h. There we go. All right. I believe that's correct now. We got some ugly negatives in there. We can try to fix those ugly negatives because they're ugly. They must be fixed. Let's get some plastic surgery going on here. Then we're going to cancel out the x squareds. Gone. The 1s, they're gone. The 5x's, they're gone. And you have before you 2hx plus h squared plus 5h divided by h. I'm going to go ahead and show, all right, that we can factor out an h in the numerator. So that leaves us with h times the quantity of 2x plus h plus 5 all divided by h. Now the h's, because it can't equal to 0, they cancel out. And your result here is 2x plus h plus 5. And we're going to put a box around this problem here. So that's right, Simone. We are using Simone, I love you. That was clever. Simone says that it's a distributive party. We just have too much fun with it. That's right. The distributive property party is in full effect here, and we definitely had our arrows popping everywhere. That's right. Simone talking about they look like pop rocks. Simone, you're on fire today. I see you showing off. I see you and Lewis over there showing off today. Y'all do what y'all can. All right. I'm going to do what I can over here on problem number 12. Okay. As we are finding and simplifying the difference quotient f of the quantity x plus h, f of x plus h rather, minus f of x divided by h, where h cannot equal to 0 for f of x equals to 1 divided by x squared. Look at this. We have a quadratic function in the denominator. Yeah, what do we do with this? Well, I know we still need to find out what that f of x plus h is. I know that for certain. So we're going to be replacing all the x's in the original function with x plus h. So it looks like this. Yeah. Lovely, right? Yeah, it's lovely. From here, let's go ahead and get this in view. Since we already know our value of f of x plus h, we know our original function, of course. It's 1 over x squared. We're going to be plugging this into the difference quotient now. So here we have 1 over x plus h squared minus 1 over x squared, all being divided by h. And once again, we have a situation, guys, where we have a complex fraction here. Yeah. That means I'm going to go ahead and simplify this complex fraction by multiplying each and every element within the rational expression by the overall LCD. And that just simply means I'm multiplying by all the different factors in the denominator. Okay? And those different factors are as follows. Is x squared times x plus h squared. That's what I'm multiplying the entire numerator and denominator by, in hopes of eliminating the complex fraction. Amen, amen. And you know what? I think I'm just going to move on to another page because I already see a hot mess coming. I mean, you can already see that the hot mess is going to be coming, right? I mean, you see this, right? You see how hot it is and messy. Therefore, it's a hot mess. We have to clean up here. We have to start anew. We have to erase this because I just messed up. There we go. Let's fix this. There we go. Better. 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 I think it's better now. Okay. This is where it's better. Okay. There we go. From here, guys, we are distributing. That's right. We're getting our arrows popping and multiplying all of this by the overall LCD, which is hx squared times x plus h squared. Oh, yes. What happens? When you multiply this first term by hx squared times x plus h squared, what happens? Way better. What you think, Sandra? Definitely better. We got a clean space for us to work in here. Okay? Let's hook this up. The x plus h squareds, that h plus x squared, the x plus h squared. That's what I meant to say. It gets canceled out. So you're left with hx squared. Then minus. Here, multiplying 1 over x squared times hx squared times the quantity of x plus h squared. The x squareds will cancel out. So you'll have h times the quantity of x plus h squared, all in the denominator of x squared, h squared, x squared times the quantity x plus h squared. There we go. There we go. I mean, it's ugly. I mean, I could try to make it look better, but I mean, it was there. I mean, you saw it. I mean, why are you complaining? Okay, I'm going to fix it. All right, I'm going to fix it. All right, that was supposed to be a square. That's a square. X plus h squared. Okay, that's a little better. Okay, I think that's a little more legible than the way I had it at first. Okay, so there you go. That's better now. Thank you. From here, one of your h's will cancel out. Okay, so we can cancel out one of those h's because they all have an h in common. In other words, you could have factored out an h in the numerator is what you could have done. And then simplify that h. We're going to go ahead and show that this is going to be x squared minus the quantity of x plus h squared, all divided by x squared. Hx squared times x plus h squared. There we go. There we go. And now, let's go ahead and expand this right side. Now, we've already multiplied this x plus h squared time and time again, guys. So I'm going to go ahead and cheat and show you that this is just going to be the quantity of x squared plus 2hx plus h squared all over hx squared. Get it right, Mr. Wet. Times the quantity of x plus h squared. There we go. There we go. There we go. But I'm not done. I'm not done here. Okay? Not done here. We're going to distribute this negative here. That's right, and we're going to continue to combine our like terms in the numerator. That's exactly what we'll be doing here. And matter of fact, I'm gonna have to steal this again because we still got to keep it clean, Sandra. That's exactly what we got to do, and we got to add another page here because we're still working on this problem. We are still working on this problem here. There you go. See, it's no wonder so many people had questions about how to use a difference quotient with a rational expression. No wonder. Because of the complex fractions in the process of simplifying this. That's why everybody was stressed out, huh? So here, guys, let's distribute that negative in the numerator. You'll have x squared minus x squared minus 2hx minus h squared all over hx squared times the quantity of x plus h squared. This is what we have thus far. We do know that the x squares will cancel out in the numerator. We know that. We know that we could factor out an h in the numerator. That'll leave us with negative 2h. No. Fix it. That'll leave us with negative 2x minus h divided by hx squared times the quantity of x plus h squared. That's what we have. Let's go ahead and get everything in view for everybody. Okay. From here, one of the h's will cancel out. So your final result here is going to be negative 2x minus h over x squared times x plus h squared. And let's see what Obina has. Obina went ahead and factored out the negative. Okay, so you could also do that, Obina. Factor out that negative, and that'll be 2x plus h over the x squared times x plus h squared. All right, that's another way to write the answer. All right, so you definitely can leave it this way. Or you could take it a step further and factor out the negative if you want to show off like Obina. All right. And there you have it. Simone says, oh, whoa, you're distributing to the left. Can you put the equation on the right of the multiplication sign on the left, or do you have to write it in that order? What are you referring to, Simone? Let me see. That was definitely messy, Obina. I told you it was going to be a hot mess. I told you it was going to be a hot mess. Absolutely. But you have it correct, and good job on that, Obina. You killed the problem. You said that I was distributing on the left, Simone. What are you talking about? Like over here? This negative here has to be distributed. Okay, so that's what I was distributing inside the parentheses. So that definitely had to be there. All right. So it was a hot mess. I told you guys that was a hot mess. Obina says starting from the reciprocal of a basic quadratic function turns this into a hot mess. Absolutely. On the previous page is what Simone was talking about. Oh, yeah. Absolutely. Yeah. You definitely can do it that way. You could have rewritten it, Simone, if you wanted to. There's a commutative property of multiplication that allows you to swap these out. Yeah, you could have written this one first and then had that one so that you could distribute in your most comfortable form of moving from left to right. But yeah, you got to get those arrows to be flexible, Simone. Stop being stingy with your arrows. You know, get ready to pop those arrows from the left to right or right to left at will, lady. Okay, step your game up with your arrows popping. That's what you need to do. You need to step up your arrows popping game, Simone. All right, this is all about you right now. All right, hook that up. Okay, so ladies and gentlemen, I just wanted to let you know, guys, that those were the problems I wanted to share with you guys today. So we had 12 problems dealing with the difference quotient. As always, we want you to subscribe to Fort Benton Tutoring. All right, there it is, FBT. You see that symbol on the video? Go ahead and click on it because you know it's going to be good. So you want to subscribe to Fort Benton Tutoring, guys. Go ahead and spread the word, share the love. And if you're on the stream or you're watching the stream, share it with somebody. All right, share it with somebody that you love. Share it with somebody you hate. All right, there you go. And also click on the bell icon. That'll get you guys notified when we're uploading new content to our YouTube channel, Fort Benton Tutoring. Check out our website. Here it is, tutoringmath.net. And thank everybody that stayed with me, that went ahead and helped me out in the stream, especially Obina, Simone, Lewis. This is in the house. We had Sandra from the beginning. Thank you so much, guys. And others that joined us today, like Michael and Kate. Genesis was in the house. We also had Chris Patrick in the house. We had Sauce God in the house, a.k.a. Darian Jones was in the house. Appreciate you stopping by. Joel was in the house today. Amen, amen. And I thank you guys for spending time with me today as we covered the difference quotient live with Fort Bend Tutoring and you. You guys take care. Peace.
Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby.